This is for you, Josh. 9.5, the alternating series test. So let our sequence be positive. The alternating series is defined as follows. Okay, this -1 to the n and -1 to the n plus 1, that's what's going to make the terms alternate in sign. So this is a test for convergence. The alternating series converges if the following two conditions are met. The limit of the nth term has to be 0, and a sub n plus 1 has to be less than or equal to a sub n for all n. Now, what does this mean? This means that if I say let a function, let me define my sequence as a function, then my function needs to be decreasing, and therefore the derivative is going to be 0. Okay, so if a sub n is this term we start with, each successive term has to be less than the previous one. This will be a short video. We're just going to go through 3 examples of this, and then the rest of this section will be a video after your quiz. All right, determine the convergence or divergence of each. So I know it's an alternating series because of my -1 to the n plus 1. First condition, limit as n approaches infinity of a sub n. That's definitely 0. That checks out. Next condition, I have to show that a sub n plus 1 is less than or equal to a sub n. So literally replacing n with n plus 1. And this here. Okay. 1 over n plus 1, bigger denominator, smaller fraction. So that condition checks out. Therefore, we say that the series converges. Now, if we wanted to check with the derivative, right, if we say let f of x equal 1 over x, the derivative of that is -1 over x squared, which is always negative, and therefore the function is decreasing. Okay, next one, alternating series. First condition, limit as n approaches infinity of a sub n is 1. Therefore, the alternating series test fails. Okay, the limit of the nth term of the sequence has to be 0. But automatically from this now, we know that this whole series diverges by the nth term test. So if the limit is not 0, then automatically the nth term test will work. Okay, last one, alternating series. First condition, limit as n approaches infinity of a sub n is definitely 0. We have to show that a sub n plus 1 is less than or equal to, won't be equal to in this case, a sub n. Okay, remember our properties of exponents. This would be 3 to the n times 3 to the first. And this for sure, 1 over 3 times 3 to the n is definitely smaller than 1 over 3 to the n. So our conclusion, that the alternating series converges. That's it for this video. Again, the second half of 9.5 I'll post after the quiz.